Thank you everybody for sticking around. We are the Menards Capstone group, and we're going to be presenting to you migrating and implementing a Cisco virtual switching system, or more commonly known as VSS, for Menards. And I am John Williams, and I was the team lead.
I'm Joseph Fuchs. I'm the testing lead and also an intern on the Menard network team.
I'm Alec Tyson. I'm the network engineer.
I'm Kwame Lee. I'm the hardware lead, and I'm also an intern with Menards, but in the hardware support.
So our sponsor for this project is Menards, who's headquartered in Eau Claire. We'd just like to thank them real quick for being our sponsor and providing us with the equipment that we worked with. Our point of contact was Justin Yarrington, who's the Menards network team lead, and we just want to thank him for being such a great person to work with and being quick with emails and helping us whenever we needed it. So for our agenda, today we'll be discussing the problem statement given to us by Menards. We'll give you an overview of what VSS is. You'll see the network topology that we've been working with throughout the project. We have a demo in a video format of how VSS is implemented, and then we'll also have a live demo of a switch failover you'll get to see in person, and then we'll wrap it all up with a summary.
All right, so who is Menards? Well, I'm sure you've walked into a Menards at some point, especially for that 11% rebate that happens all the time. Well, they have over 300 stores in 14 states, and they're a very fast-growing company. So Menards IT really needs to be able to respond and adapt to these needs. And they really need reliability and speed at these data centers, stores, and distribution centers. We also need to keep in mind Menards only has one networking team to manage all of these locations, so they're not able to fly around constantly. So just to go over the problem statement, Menards has a large spanning tree network with redundant core and distribution layer switches. And this has been going great, it's been working for a while, but with business growth, it now poses its own challenges for management and scalability. And they're also unable to fully utilize the technology and performance of their switches. So Menards looked into Cisco virtual switching system and tasked us to see if that's something they should implement in their production environment. Just to go over their current network, we have our end users at the bottom here. They all connect to the access switches. We're only showing one here, there's actually a ton of these. So they all pull up the access switches. Aggregation switches collect all the access switches, and then the aggregation pulls everybody up to the core. The core is currently running HSRP on both these routers. We have an Ether channel in between. And then when I mentioned that the switches are kind of they're not really utilizing the technology to its fullest, I'm referring to they're using like an odd, even VLAN situation. So all the even VLANs will be on this switch, all the odd. And basically, if there's a lot of load on the odd VLANs, only one switch is getting hammered, the other switch isn't doing that much. And then, of course, we just have our two routers, one to go to the ISP and then a backup for 4G.
So what is virtual switching system? Virtual switching system, or VSS, is basically linking two switches, in our case, two 4500X switches together. And to do that, we'll be using a virtual switch link, or VSL. And that's an Ether channel connecting to two switches, and then logically making it into one. And then that would also be one domain as well. And what that VSL does is it allows the traffic to be configured from one switch, the management switch, or the active switch, to the standby as well, so they share the configuration. And then moving on, I'll pass it over to John to explain why one should use VSS.
All right, thank you, Kong. So like Kong just said, single point of management. Physically, it is two switches that are now converted to VSS. Logically, it is one now. So what you can do is on the active switch, that is where you configure everything, whatever you're going to configure the ports, access list, whatever you're going to do, your routing information, all that stuff. It's all done on one switch, so you don't have to, if you're SSH, you can do a second switch, or constant a second switch if you're in there. Load balancing, that is done through the Ether channel load balancing algorithm. Like Alec was saying, these two switches are running odd even VLAN, which is industry standard usually. But with VSS, they can load balance between these two. So that these switches will automatically load balance between the two. So let's say there's a lot of traffic on odd VLANs, there's a lot of traffic on VLANs 1 through 300 or whatever one day. That switch can now load balance it across two switches instead of just one switch getting hammered all day. So that's really nice with VSS. Stable switchover and non-stop forwarding, or SSO, NSF, that is where the traffic, it never stops flowing to these switches, never stops. So if you have a catastrophic failure for whatever reason on your active switch, that goes down, your standby goes, oh, I gotta go active, so it's gotta go up. That traffic never stops flowing, so there's never like, I don't know where to go. And it just stops and then it continues. It just keeps going and keeps going because it knows where to point it. So that's really nice, it minimizes your downtime significantly. Multi-chassis Ether channel. So as you can see here, like this is kind of like what Menards network is right now. You have your access switches, or your AG switches, sorry, that connect redundant connections to both switches. With VSS, that can now be converted to a port channel because logically it is one switch. So that gives you more bandwidth and more throughput, so you can transfer data a lot faster and so forth. Moving on, Justin and the Menards team they wanted us to see if VSS can replace HSRP and also prevent what's known as a split brain. A split brain is where you have HSRP running like on this network right here. You have your .1 in the center, .2, .3 on the other side. It's pretty simple stuff. When that ether channel goes down, those two switches lose their connection to each other and they both think that their partner went down. When that happens, they both take the .1 address, and as you can see, that's probably an issue. With those access layer switches and all the PCs down there, they're trying to send data to the .1 address. They don't know where to go. They're like, well, .1's here and .1's here. Where do I go? So it bogs down your entire network, it clusters it up, and it becomes a huge mess. The dual active fast low, on the other hand, is dealing with VSS. If that VSL link goes down, they both go active. So you have two switches with the exact same config, which duplicate IPs, duplicate routing tables, duplicate routes, everything. So that's just a big no-no. With the dual active fast low, that's a separate connection. So you can have like a separate connection to these switches that's dedicated to dual active fast low. So if that VSL link goes down, it doesn't matter. Like your standby switch will stay standby. If the entire switch goes down, so like they lose connection to the dual active fast to low interface and the VSL link, then the switch will go to active. Also continuing, it doesn't require those big bulky stacking cables. Justin actually brought this up to us. This also allows, with these stacking cables, it's just those big, they're really tiny, they're about that long, like a foot maybe. The VSS, all you need is an Ethernet cable. And Justin brought this up to us as well. This also allows you to do like dual rack redundancy. So if you have switches in separate racks, you can string a really long Ethernet cable instead of trying to like finagle a little 1 foot stacking cable across these. It's also available on multiple switches, 65, 68, and 4500 switches. We are actually running 4500X switches that Menards provided us. We were supposed to get the 9500s, but unfortunately Cisco wasn't able to procure 2 of them for us. They can only get us 1. So Justin and his team realized, they're like, well, they're probably not gonna get the switches in time, so let's give them our 4500s. It would have been nice to work with the 9500s, but stuff just didn't work out, so that's okay. And why that says coming soon. So VSS it wasn't available on the 9500s when we first started. It was coming. And the reason for that is so many people wanted to upgrade their network to these newest and greatest, latest, whatever, 9500s, because they're a lot faster, they're newer, a lot more stuff you can do with them. But so many people love VSS, and like, well, we want to upgrade, but we don't want to go away from VSS because they like it so much. So Cisco said, fine, we'll give you VSS. So that kind of gives you an idea of how much people really like VSS.
So there are a few disadvantages of VSS or reasons someone might not want to use it. The first is when you implement VSS, you have to reconfigure the ports on the secondary switch. So as you can see right here, these two are a VSS pair, and you implement VSS as this is the secondary. The only ports that will have the configurations on them is the VSL ports right here in between the two. And then these two, the configurations will get wiped on those, so you'll want to set those back up to trunk your VLANs. Another downside of VSS is that if you ever want to go back to a standalone mode or downgrade VSS, both the switches have to reload in order to do that. So you can expect some downtime in your network. Each switch takes about 8 minutes to reload. And then along with converting back to standalone mode, it wipes the port configurations on those switches too, so you want to reconfigure those how they were set up on your previous network. And then also VSS, it will not operate if you have 2 different iOS versions on the switches. If you try to implement VSS when one switch is running a different version than the other, VSS will just not implement and it won't work. The VSL connection will not form in between the two. And then with that, you want to keep in mind when you're upgrading in the future, the iOSs in the future, you need to use Cisco's in-service software upgrade. If you do not, you will not be able to implement or put on the iOSs on the switches. What the ISSU allows you to do is upgrade both of the iOSs on the switches at the same time without either of the switches going down. Granted, you have a second supervisor engine. If you try to upgrade the iOSs without it, you can either do one switch at a time, which won't work because then you'll have that mismatch in the iOSs. And if you do both at the same time, you'll have to reload, which will cause both of the switches to go down, and then you'll lose that whole point in your network. So So for our project deliverables, we had 4 main things we had to do. We had to design a network that replicated Menards' production network, which we were able to do in our lab environment, and then we could test VSS on that. We had to document the advantages and disadvantages of using VSS, which we just went over. Along with that, we have to develop a procedure for migrating to VSS from a remote location to make sure that's possible. And then we had to document and present a failover scenario, which you will see later in our live demo.
So for physical hardware, at the top we have a Meraki teleworker. Teleworker Z1, which John provided us. That was our router, our source of VPN. That way we can SSH, since Menards does want us to SSH since they want to do it remotely. So that's how we are SSHing into our network. And then all the devices here, the Cisco switches, are all provided from Menards for us to use. At the core layer, we have two 4500Xs. And then at our aggregation level, we have two 2960s, and one 2960 we are using at the access level. So here's the network topology. On the left is the Menards network, which Alec covered earlier, but as he stated earlier, at the access there are more than just the one switch, but just for showing purposes, we're going to show just the one. And on the right-hand side is the our lab network, imitating the Menards network. And here we have at the core, we have a route pointing out towards the aggregation, out toward the router, which is what access the internet for us. And then here's the network topology with VSS. So it's basically just taking the core layer and squishing it into one logical domain or one virtual domain. And then along with that, please know that we will be creating MECs like John stated earlier, since they become logically one switch, so Ether channel is available between the switches.
And for our testing plan, there's 4 big things we have to test. The first is the total downtime during the conversion to VSS. Along with that, failover of a single switch, which again you'll see in our demo in a little bit. We have to see if it was possible to remove spanning tree, and if so, how we would do that. And then with that, we need to make sure it's really important for Menards, since they can't be at every location physically, that they can do this remotely through SSH.
Okay, so who here likes to be a spanning tree? You do?
So it prevents a lot of network congestion, yeah.
Well, I don't, because it gives me a lot of headaches some days.
That's a good question.
Who likes configuring?
Yeah, who likes configuring? That's a better question. So with VSS, it is possible to get rid of spanning tree in a small network. So if you were to take, say, like this little network, for example, logically this is one switch, but there's 2 switches up here, so spanning tree doesn't happen between these 2 switches. And then you would just have these 2 switches down here. You don't have a loop. Right here, you just got a little triangle right here. With Menards network, unfortunately, they cannot get rid of spanning tree because they still have this diamond pattern right here. And keep in mind, those access switches, there's multiple of them. So you have multiple loops throughout that network, and removing spanning tree is just not possible. It would create way too many issues. The only way you could get rid of spanning tree is if you did it manually, but no one wants to do that.
All right, so now we'll go over our live demo. John, if you want to do the next slide real quick. Just to go over what the first live demo will do. So we're just going to do a video because of time. We want to just show the whole process of implementing a network from no VSS to VSS. So we'll go ahead and pull that out. There's 2 parts to it. There's the configuration, getting the switches ready for VSS, but then there's the reloading. So they're currently in like a standby mode, or I'm sorry, standalone mode. But then when we do the reload, they'll actually boot into this virtual switching. So as you can see, we're first going to actually range into our interfaces. We're going to do a no channel group command. We're just getting rid of an Ether channel. So what happens is if we need to create this virtual link on the Ether channel. But when we try to do that with an Ether channel that's already talking to each other, it actually doesn't properly configure VSS. So we actually have to remove it first, and then we'll actually create another Ether channel and then create that VSL link. This is us getting rid of that, and then we're going to do a switch virtual domain 1. It's going to be the same on both. And then the next thing is we're actually going to name the switches. So distro 1 will be switch 1, distro 2 will be switch 2. And then as you can see right here, there's a priority of 110. So by default, the priority is 100. We want distro 1 to be the active switch, distro 2 to be standby. Highest priority wins, we're just going to change that to a 110. Now we're creating our port channels. As you can see, this is port channel 5, port channel 6 on the bottom. So they actually have to be different for VSS. We're going to go ahead and unshut that, create the switch virtual link on both. And then we're just going to go into our individual interfaces and assign that port channel to them. Now, that's the configuration part, but now we need to do the reloading part. So now we're going to be pinging Google's public IP, and then we're going to be doing that switch convert command out there that you can see. And then now this is 2 HSRP switches with 1 dropping. So you're going to see an HSRP failover. You should see it takes about 10 seconds for HSRP to do that. And there it is, we got our ping. Now the next one is a VSS switch going to HSRP. I'm sorry, we have an HSRP and a VSS switch. So the HSRP is going to go on VSS and do that conversion. And as we can see, VSS should be able to do that a lot faster. And there we go, about 4 seconds for VSS. Now, if you want to go back to the PowerPoint real quick, we're going to do our actual live demo. So that was like a past demo of our video. So for this scenario, we're going to have VSS running, 2 switches with VSS. We're going to pull the plug on one while we have a ping out to the. We can't go outside of the network just because when we plug in the Ethernet port on Stout's network, it doesn't give us access to the internet, but we can ping our router just to simulate that.
And then just going back onto the conversion, that time does vary for us. It was just that in this case, when we recorded, the times were 10 seconds for the first and 4 for the second. But then there were times where it was up to 45 seconds long for the conversion.
Yeah, so we got lucky with that 4 seconds. But it can, it's never been over a minute. So it's usually the highest we saw was around like 44 seconds. So for downtime, I would say keep it about a minute, just to be safe. How's it going over there, guys?
So right now, we're going to be consoling into the actual standby switch, and then we will actually be simulating a catastrophic failure of the active VSS switch, and we'll kind of show that up here on this projector. So this is, again, just simulating what would happen if your active switch actually did get struck by lightning, power supply failed, whatever. Something happened, and it's not good.
I'm Josh. Is there a light switch behind me? Which one is it? Go on.
That'll work. Alright, so what we'll be doing is we can't get internet access into this room, otherwise we would be doing this remotely. But unfortunately, we can't, so we have to just ping our router interface, which is basically still simulating the same thing going out to the internet. So right now, we are consoled in to the standby switch on the right-hand side, and then we're doing that continuous ping out to the internet, so it'll show you how long the network actually goes down. So right now, I'm going to unplug the active switch. You'll see on the right-hand side, the switch is now going active, and we are losing a little bit of connection on the left-hand side. So now the standby switch is now in active mode. There is one issue, like Joe said before, what we had to do is when these switches do come back up, you see this 10 gigabit 2, 1, 3, and 4. Those are ports on the standby switch. So when that standby switch goes into VSS, all those ports, all these ports used to have like a black hole VLAN configured on them, they all get wiped. So you have to go in after the switch migrates to VSS and make sure you set your trunk ports going down to the aggregation layer. Otherwise, this would not have come back up and you would have been out of your network completely. So that does conclude our live demo for this. Go ahead and wheel this back out there.
do the next slide.
All right, so just to go over the problems that we ran into when we were working on this project, the first one is misconfiguration. So when you're working with the technology that has to do that reload, it has to go from that standalone to virtual. If you misconfigure something, you're going to have to go all the way back to standalone, back to VSS. So it just takes a lot of time, that 8 minutes, 7 minutes of downtime. It turns into you misconfigure something, well, that's 14 minutes of kind of waiting there to retry.
Another problem we ran into, so we're 99% sure this was just our hardware issue, because what would happen is on that second switch that we got, the second 4500, for whatever reason, every time we would reload it, it would boot into the Enterprise Services license feature. And we asked Justin, we asked Nate, we Googled on forums, we looked everywhere, and we could not figure out why it was doing that. So we think it was just a hardware issue. So every time we were trying to migrate to VSS, do the commands and convert it over, we always had to double check that license feature. Otherwise, the VSS pair will not form because it is running different license features. So distro 1 is running IP based, distro 2 is running enterprise services. So that's definitely something you have to watch out for.
And going off of what John's saying, it leads into the next problem, which is the reboot loop. And so every time we have that issue with the licensing, we would get stuck in a reboot loop, where when prompted, we click Control-C, and then we get into ROM mode. And then from there, we have to technically clear config all to wipe all the configuration on the switches, which leads us to the last problem.
So that would also wipe the boot variable that we had set. The boot variable pretty much tells the switch what to do when it boots up. So with that wiped, normally we have it pointing to load up the iOS. With that gone, it would just put the switch into ROM mode.
So in conclusion, we do recommend going to VSS. The pros outweigh the cons by quite a bit. The only cons you really have is when you're upgrading iOSs, and even if you do that, you can do it through ISSU. The benefits, you have a single point of management. You can configure all from one switch. You don't have to swap between switches to do that. Load balancing, you can do load balancing through that Ether channel load balancing algorithm, so both switches can have equal load on them. Your multi-chassis Ether channel, it's really nice because you don't have to run, you can just literally run one connection to each switch, and then you have an Ether channel right there, so you can get more of your bandwidth and more throughput. And utilizing the equipment to its fullest, like I said, with load balancing, you can load balance all those processes so one switch isn't getting hammered all the time. And so those switches can kind of take a break and work together at a reasonable load. So lessons learned, I definitely learned from this capstone that time management and just don't take time for granted. Don't take downtime for granted or boredom for granted. We were unable to get our switches right away. We got them a little late, a couple weeks. But in that time, we were all friends. We were hanging out together. We went to the Silver Dollar, our local area, for a drink, food, and stuff like that. But as soon as Capstone revved up, that was every night of the week. Just going in the lab, slaving over the equipment, getting everything to work, testing everything that we were supposed to, figuring out those tiny little issues like that license feature issue. It's just, I learned just don't take your time for granted, whether it's downtime or if you're bored or not.
And when we first started the project, we had to figure out a way of communication. So we were actually going to start out with email, but as you guys can tell, as email kind of piles up, it just gets really messy. So they actually suggested using Facebook Messenger, and I've been pretty against that. It just doesn't seem like a tool that I've used, but after using it, actually was really helpful. Not only do you get like an instant notification like text message, but you can see each person that's read the text, and then on top of that, you can actually schedule things. So if you send somebody an invite, you see who's coming to it, and then everybody gets a notification when the event is going to happen.
So one of the personal things I learned is just not be too afraid to talk to someone or get to know them right away. I've had classes with all these guys before in the past many times, but I never really talked to them too much. Through doing this capstone, I think we all got to know each other pretty well. We're all really good friends now, and I wish I got a chance to know these guys sooner.
And the one thing I learned was that there are no dumb questions. As the semester progressed for us, we were presenting our slides, and then we got questioned about the topology, and we were pretty confident that was the correct topology, but just that little bit of doubt made us doubt it, so we had to double check with Justin just to make sure we had the correct topology, and that was my lesson. Just there are no stupid questions, just double check it.
Okay, so we want to obviously thank Menards for providing us with this equipment, this experience. We got to work with some enterprise level networking equipment. It was a really cool experience. Thank you to Justin and to Nate, who's not here today, but they both were able to answer our questions, answer our emails in a very timely manner. Pretty straightforward, pointing us in the right direction when we need to. We also want to thank UW Style for this program. Without this program, we would not be anywhere near where we are today. just the learning resources that they give us, the opportunity to learn, the different internships that always come to this program. People come looking for us, like you guys from the industry. So we just want to extend a huge thank you to both of you. With that, does anybody have any questions for us?
Now, time is kind of constrained to come in late, but do you think you can be more consistent with the upgrade process? I know you said it varied from like 4 seconds to 4 to like a minute. As in, a plant that never shuts down, that's a pretty big deal. It costs thousands of dollars.
We migrated to VSS from like the bare bones up to VSS at least a dozen times, and it did vary. It never went over a minute. Distro 1, the first switch, would always be between 10 and 25 seconds. The second one varied so much, and we think that was because HSRP, what VSS does is it takes that HSRP configuration and it puts it into VSS, so that you no longer have a .1 address like a virtual IP, it puts it all into VSS. So we think that was part of the issue, and maybe Spanning Tree was also configuring. So we didn't have time to test all of that, like different scenarios with soft failing over HSRP or trying to mess more with Spanning Tree, but we do think if we did test that some more, we might be able to get more consistent times.
So you mentioned the hardware platform and the problem there. Is there any way to identify that before proceeding with this? To make sure that none of the switches in the current environment are affected by this problem?
Like the license feature issue?
Yeah, booting into the other
Yeah,
ones.
so you can do the show version and it'll show you like what it is running. So distro would always show IP base, and then it also shows you the next reboot, what it will boot into. So that's the only way we were able to tell if it would boot into the correct one. We'd have to check that. And if it was currently running IP base, next reboot will go into enterprise services. Then you have to go in there and set the license feature level. Other than that, through all my searching on forums, through everybody's searching on forums, we didn't really find a way that you can narrow it down to like a specific maybe iOS issue or a hardware platform issue.
How does this feature play into hardware replacements? You have a failed switch or you want to upgrade switches. Is that possible with this feature turned on without an outage?
Without an outage, no, probably not, because you have your two different switch platforms, and from my understanding, it will not work between two different like switch platforms, so you have to have dual, like the exact same switches from our research. So you would have to schedule a downtime, get those switches up and configured beforehand, and then replace them in the environment.
What about replacing, like, in-service replacement, something wrong with the switch, but that switch port's responding not the exact same?
That should not be an issue. We were using SFP-based switches, so they were easy to pull out and pop back in, and we never had an issue with doing that.
So if you're replacing the same model,
Sorry, what?
if you're replacing the same model, I'm assuming that's pretty easy, that you just have to tell it which switch.
Yeah, if you're replacing the same model, what would happen is like what we showed there, if you pull power on the active switch, so you bring that one down, you only have one switch running. So if you were able to take that, like a same model, like a third 4500X, and you wanted to replace it in there because your other one died for some reason, as long as your configurations match, your iOS matches, your license feature matches, everything matches together, then you shouldn't have an issue. Okay, I guess we'll, time constraint, we'll hand it off to the next capstone, which is the Heartland team with AWS.